Let's get started. Today we've got two things to talk about, some polynomial terminology, and then we're going to multiply some binomials together. So just some words we need to be familiar with first. From last year you had the word term. The term is a product of any coefficient, that is any number, put together with any variable, any letter. So for example, 7x here would be a term. The number part 7, the coefficient, and the letter part the x. So any combinations of letters and numbers together will give you a term. Also, the degree of that term is the sum of the exponents. So if I had something like 5m cubed, that would be degree 3. With 4x cubed y squared, that's degree 5. So you just add the exponents together, 3 plus 2 here for degree 5, and that's it. A polynomial is formed by adding or subtracting terms. So I've got 3x squared plus 4y here, just as an example. You can see we've got a single term here separated by a plus sign with another term here. So these two terms put together with a plus sign here or minus sign will give you a polynomial. The degree of the polynomial is the highest degree of any of its individual terms. So again, I've got another polynomial here. You can see that if I look at the individual exponents on the first term, I've got a 4 and a 3 for 7. And on the second term, I've got 2 and a 7. If I add those together, I've got 9. So overall, this polynomial will have a degree of 9. It's the highest term degree that you're interested in to classify that polynomial. Okay, next, we can classify then by the number of terms in the polynomial. We can also classify by the degree. So to start off with, if you have a single term, that's polynomials known as a monomial. If you have 2 terms, it's a binomial, 3 terms, a trinomial. If you have 4 or more, anything after that, it's just simply called a polynomial. Poly meaning multiple or multi. So anything more than 4 terms, 5 terms, 6 terms, 7 terms, whatever it happens to be, just going to be called a simple polynomial. We could also have classification by degree, as we saw. This would be a degree 1, and you can write the 1 here if you'd like on your variable. Any work that you did last year with y equals mx plus b, we just had single x's here, so degree 1, that's a linear, that's all your straight line work from last year. This one here, 6x squared plus 4x minus 2, you can see with the exponent of 2 on the x, that becomes a degree 2, and that's now called a quadratic, and that's going to be really the focus for this year in grade 10. Lots of quadratic work coming. And the next one we can see here with the x cubed, that will be a degree 3, so it's called a cubic. More concentration on this for next year in grade 11 rather than this year in grade 10, but it's nice to know the name this year. And lastly, you can see there's no x's here. That's simply called degree 0 or a constant. So we could write in here, if you really wanted to, an x with an exponent of 0 on there. We know that x to the exponent 0 or anything to the exponent 0 is a 1. So this is really 4 times 1 or just 4, as we would normally write the number by itself. So degree 0 here, again going along with the exponent, and simply called a constant. So a couple of examples here just to classify, 2 classifications, number 1 by degree and number 2 by the number of terms. So for this one here, I can write the 1 on here to help you out. The degree here will simply just be degree 1, which makes it a linear expression. And again, from your work last year, y equals mx plus b looks very similar to that. And the number of terms, well, there's 2 terms here, which makes it a binomial. So both classifications on that one. And over here, same thing. If I look across on each term here, I can see this is the highest degree, so that's going to be a degree 2, which makes it a quadratic. And the number of terms here, 1, 2, 3, would make this expression a trinomial. Okay, so fairly straightforward as long as you know the names, of course, and are able to count the number of terms to classify it as each of these classifications, and you're able to come up with the degree as well. So 2 classifications when you talk about polynomials. Okay, also, just to finish it off, some multiplying of binomials. All right, to multiply binomials together, we need to use the distributive property, and what we're going to do is something called FOIL, four-letter F word for you, and that stands for first, outsides, insides, last. And what that means is there's 4 multiplications that need to be done when you're multiplying binomials together, and we'll go through all 4 of them together. And we're going to start with firsts, that is the first in each bracket. So if I do that, first times first will be x squared. Then we do the outside multiplication, so x times 3, sorry, negative 3 for negative 3x. Then we can do the inside multiplications. 1 times x for 1x. And finally, the lasts get multiplied together. 1 times negative 3 for negative 3. So 4 multiplications that need to get done there, and you'll get 4 terms down here. And you'll notice at the bottom we've got like terms in the middle, which can be added together and simplified. So we'll do that, leaving you with x squared minus 2x minus 3, and that would be a complete solution for this question. So 2 binomials multiplied together should give you a trinomial when you're finished, in most cases. Some other examples down here, again, just go through each multiplication in order and then collect your like terms to finish it off. Firsts together, and you can finger point, I like to finger point. So firsts together, 2x times 3x, 6x squared. Outsides, 2x times 2. Insides, minus 3x. And finally, lasts, negative 1 times 2 for negative 2. And again, you can see when you multiply the 2 binomials together, we've got 4 terms here for the 4 multiplications, but we do have the like terms in the middle, which we need to simplify. And if we do that, we get 6x squared plus x minus 2. And again, another trinomial there. Another example here, you're going to see this quite a bit, so take care when you are multiplying this expression together. I think the safest way to multiply this is to FOIL first, multiply these brackets together first, and then multiply everything by 2 later. Some people like to multiply the 2 first, multiply the 2 into the first bracket, and then FOIL afterwards. I find that when people do this, they like to draw the arrows on the first bracket, which is great, they get that multiplication, but then they extend and multiply into the second bracket as well, which is not correct. So I'm going to erase that quickly so that you don't remember that. And I'll probably erase this part here too, because I think really the safest way to deal with this question is to actually do the FOIL part first. So I'm going to say FOIL first, and then we can multiply the 2 into the bracket later. So if I leave the 2 where it is initially and do the FOIL part, I've got 15x squared for the first, outsides plus 3x, insides minus 35x, and lasts negative 7. And I'll collect the like terms here. So 2 times 15x squared, 3 subtract 35 for negative 32x minus 7. So again, the 2 binomials multiplied together give you a trinomial. And then finally, to finish this off, we can multiply the 2 into this bracket and get a final answer. So 30x squared minus 64x minus 14 would be the final answer there. And that's pretty much it. Now, there are some special cases that I do need to show you, so I'll just quickly do that as well. binomial multiplied by itself. And secondly, we've got a binomial that looks the same, except one has a plus sign and one has a minus sign. So a binomial multiplied by itself, I think, again, there's more than one way of doing this. I think the safest way is to actually write out the bracket twice. So write out 3x plus 1 twice, and then just do the usual multiplying of the two brackets using FOIL. That's the safest way, I think. So if we do that, first times first, 9x squared, outsides, plus 3x, insides, again, plus 3x, and last, 1 times 1. Some like terms in the middle here that we can simplify. 9x squared plus 6x plus 1 should be the final answer there. A lot of people try and square the first part to get 9x squared and square the last part, but then they forget about the middle part here. So be safe, write it out twice, and come up with that middle term of 6x in the middle. Over here, no tricks really, just multiplying the two brackets together. So first times first again, 4x squared, outsides, minus 10x, insides, plus 10x, and last, minus 25. And the nice part about this particular question is, with those opposite signs, you can see we've got like terms in the middle here that will essentially give 0. So 4x squared minus 10x plus 10x is 0. We don't have to write anything down for that, and leave it with minus 25, and we're done. So there is no middle term here because of the opposite signs, but there is a middle term here. We've got the same signs. Okay, so get some practice, and if you have any questions, I'll answer them in class.